Hey everyone, Mr. Newman here, and today we're going to learn about comparing exponential functions. This is where we take two different functions and we look at them, we answer questions based on the two functions. So for example, you see here I've got two link sheets, one right here on the left and one right on the right. And these link sheets, all of them represent a certain function. So you see I've underlined the f of x on the left here. This is the table for f of x, the graph for f of x, and just a few words saying what's going on with f of x. And then on the right here, we've got g of x, and again, the table for g of x, the graph for g of x, and some words that describe what's going on with g of x. And other peculiar thing about this video is this is going to involve a lot of me wanting you to answer the question first, trying out the question, seeing if you can figure out what's going on, because each question is very different, and the more you can learn to think about it and answer the questions on your own, the better you'll be when we get to the quiz. So let's do this first one. When x is greater than 0, the value of f of x is less than the value of g of x for every value of x. First thing, before you answer this question, I want you to understand that when we say the value of f of x, we're talking about the y value of f of x. So remember, our x is there and our y is there on the axes. So when you're talking about a specific point, you go left to right x, up down y. If x is greater than 0, that means to the right side of the y-axis, everything on the positive side along the x-axis. And again, for our g of x, that's where x and y are. So I want to circle these points right here, 1, 6 and 1, 6. Those 2 points are the same. So that is a case where x is greater than 0, but the value of f of x is not less than the value of g of x. They're actually the same. That makes this first statement false. And the reason is because, remember that our f of x and g of x, that's the y value here, so I'm looking at the 6. When x is 1, f of x is not larger than g of x because they're both 6. So that is an example of a good explanation. Go ahead and try the next one on your own. All right, have you gotten it? Let's look at the y-intercepts. One of the things I'm going to do, is that I'm going to try to show you guys multiple reasons, multiple different, looking at the graphs and the equations and the tables and even the descriptions of why the answer is the way it is. Because you can use whichever method or whichever representation you want. You can use the graphs and compare those. You can use the tables and compare those. So the y-intercepts, we know that that's right here. I marked them both in blue. You notice on the right, g of x is 2 for a y-intercept, but on the left, f of x is 3, so they are not the same. That's false. One y-intercept is 3 and the other is 2. All right. Again, I'm going to show you in the video the graphs, but we go on down and we have now number 3, 4, and 5, and 6. So before you try to answer number 3, one thing I want to tell you is that as x increases without bound, that just means it keeps getting bigger and bigger, and there are no asymptotes. In other words, it doesn't get closer to something, but keeps on getting bigger and bigger forever. All right, you answer it. So remember that f of x and g of x, that is talking about the y values. And as x increases without bound, that is true. A good explanation is because they are both exponential growth functions. And that means they're going to get bigger and bigger as you go to the right, as x gets bigger. This next one should say when, not as. When x is less than 0. Go ahead and try it. All right, when x is less than 0, the value of f of x is less than the value of g of x for every value of x. Well, we can look at the negatives. So when x is less than 0, the value of f of x is less than the value of g of x for every value of x. Remember that f of x is talking about the y value of f of x, and g of x is talking about the y value of g of x. One other thing I can do to help me out is I'm going to sketch the graph of g of x on the left there so that both graphs are on the same grid. And this will help me out a little bit because in this way, now I can compare them. The other thing you could do is you could type both of these functions into your graphing calculator and then you'd be able to see both of them on the same graph when you press graph. So, well, another way I can answer this question and look at it is look at the tables. So see, the two places I circled are where x is negative, and when x is negative 1, f of x is 1.5, but g of x is 0.6 repeating. So that right there is enough for me to know, and just likewise the one above it, that this statement is false. And I could say, for example, when x is equal to negative 1, f of x is 1.5, and g of x is 0.6 repeating, so f of x is greater. That means f of x is not less than the value of g of x for every value of x less than 0. For the next one, the two functions f of x and g of x have the same horizontal asymptote. Remember what an asymptote is? I'm going to sketch them both on here. The asymptote is the line that the function gets closer and closer to, but never touches. And both of these have an x in a horizontal asymptote of y equals 0, or of the x-axis. So that makes this statement true. For number 6, the growth factor is the number you're multiplying by over and over. So you see that's right here on the equation. F of x, that's 2. G of x, that's 3. The growth factor of f of x is 2, while the growth factor of g of x is 3. That means that this statement is false. Another way to see that is that's what's being multiplied by over and over in the table. And yet another way to see that is in the words, in the sentences. It's what it says, where it says multiplied by 2 each step, and then multiplied by 3 each step. Each of those are the growth factor. All right, both functions f of x and g of x are examples of exponential growth. This statement is true. The reason, or a good explanation, is that both functions are exponential and they are increasing. So both are exponential functions that are increasing, makes both of these exponential functions. You could also talk about the equations, how x is in the exponent, and b is greater than 1. B is that exponential growth factor we just talked about up above. For this next one, when x is greater than 1, now unfortunately I don't have that on this graph because the graph is too small, but you're welcome to type it in your calculator and look at the graph above that. We say the value of f of x is less than the value of g of x for every value of x. I'm going to show you how to figure this one out just using a table. You see this right here? That is one place where f of x and g of x are both greater than, where x is greater than 1, and we can compare them. Is f of x less than the value of g of x? Well, it is here, but that doesn't make it true everywhere necessarily. However, if you think about what the sentence is saying, we're going to multiply by 2 to get the next step for f of x, and we're going to multiply by 3 to get the next step for g of x. That means that f of x is always going to be smaller than g of x because you're always multiplying by a bigger number for g of x. So f of x will always be less than g of x. That is the y values, and that's what we mean when we say f of x and g of x. So this statement is multiply by a smaller number every step. This statement is true. All right, on the back here, the challenge is that these values are not included. That means that we have to figure out all the other parts of the equation. Now, one small little problem here, I have a typo there. That should say g of x is 2 to the x minus 1. That's what the graph represents. But sometimes I won't even give you an equation. I'll just give you a graph on one side and a table on the other, or an equation on the other, or just a word description on the other. And what we have to do is we have to learn to compare them even though we don't have all the different parts of the function. In my opinion, the best way to compare them is to write them down somewhere so that we do see the same description. It could be graphing both of them, or it could be writing down the table for both of them. However you work best, you should do that method in order to compare them. So what I'm going to do here is I'm going to show you how to get all the different parts of the function. On the left here, we can make that table just by plugging in those values. So you plug in 0 into that function up above, you get that point right there. Plug in 1, you get that point. Plug in 2, and so on and so forth. Another thing you could do is you could graph this in the calculator and just go to the table of values and look at that table of values. Now I'm going to connect those, and that is what my function will look like on the graph. On the right side here, I'm going to plug in 0, I get 0. Plug in 1, I get 1. Plug in 2, I get 3. And if I did not have the equation there, I could approximate those from the graph. Notice I see that the one on the left starts at 2 and has a factor of 1.5. In other words, it's multiplied by 1.5. The one on the right is always 1 less than 2 to the power. So if you do 2 to the 5th and then subtract 1 from it, you get that number on the right. So when x is greater than 0, in other words, when x is positive, the value of f of x is less than the value of g of x for every value of x. Let's test it out. One of the places I can do is just start looking at positive x values. So we look right there. Or we could also graph it on the same graph, like that. F of x is the blue one in that case. G of x is the red one. So when x is 1, f of x is 3, and g of x is 1, that means that statement is false. Because f of x is not less than g of x there. The y-intercept of g of x is the same as the y-intercept of f of x. Are the y-intercepts the same? Well, the y-intercept of g of x is 0, and the y-intercept of f of x is 2. I circled those on the table, on the graph, and I also circled them right there on the table. So that is false. Oops. For the next one, let's first fill in all these. As x increases without bound, that means as x gets bigger and bigger, f of x and g of x both increase without bound. This statement is true because they are both exponential growth functions. For x less than 0, the value of every value of f of x is less than the value of g of x for every value of x. For this one, I'm actually going to draw the horizontal asymptotes. And this is going to help me out because this is going to show me where these numbers go. You notice that g of x, the red function, is less than f of x for all the negative values. So if this statement were switched, if we said the values of g of x is less than the value of f of x for every value of x, it'd be true. However, that's not true, so we need to switch those. Another place you can look is look at the tables here. You see how for negative 1, f of x is bigger. For negative 2, f of x is bigger. So once again, we see, either looking at the table or looking at the graph, this statement is false. The two functions f of x and g of x have the same horizontal asymptote. Well, remember, a horizontal asymptote is the number that you get closer to, but never touch. And you notice I drew them on both graphs, and they are not the same thing. So f of x has a horizontal asymptote of the x-axis, while g of x has a horizontal asymptote at y equals negative 1. That makes that statement false. The growth factor of f of x is always larger than the growth factor of g of x. That statement is, well, what's the growth factor of f of x? It's 1.5. The growth factor of g of x is 2, because that's 2 to the power. So 1.5 is not larger than 2. Now I'm going to put one caveat here. This is a tricky question because in this situation, we don't see the numbers being multiplied by 2 on the table each step. That's because of this minus 1 here. So we have to be careful when we talk about growth factor that we are describing this base right here. And to be perfectly honest, I don't completely like that question, so that kind of question will hopefully not show up on your quiz. Or I will make sure it does not show up on your quiz. All right, that means that statement is false. Okay, last one here. Yep. Both functions f of x and g of x are examples of growth functions. I feel like we just answered that. Oh no, we did not yet. Both are increasing exponential functions, and b is greater than 0. We just talked about the growth factors. Both of them are getting larger as you go to the right, so they're both exponential growth functions. That's true. At x equals 1, the value of f of x is less than the value of g of x for every value of x. Why? Well, at x equals 1, notice that we're talking about the y values here. We only have one point to test. We can see that right there in the table. That 1, 3 is actually bigger than 1, 1, so this statement is false. G of x is less than f of x, not the other way around. 3 is not less than 1. Now, both inequalities are always true, and I wrote down two inequalities here so we could think about this. F of x is greater than 0. What that means is that the y value is greater than 0. Look at this. All of those are positive. So that statement is actually true. Remember, our horizontal asymptote is the x-axis. That means that this function never drops below the x-axis. It just gets closer and closer to 0. So all of those are positive. That's always true. But if we look at g of x, notice already I've circled one where the y value is negative. So this statement is not always true. And you see on the graph it goes below the x-axis. That means there are y values, in other words, g of x, is not positive. So this statement is false. Thank you very much for watching.